Welcome back everyone to Data Science for Everyone. Today we're going to be talking about covariation. So if variation describes within a variable, covariation describes behavior between variables. So covariation is the tendency for these values of two or more variables to vary together in relation to one another. Now, the best way to spot covariation is definitely to visualize these things, okay? To visualize the relationship between these values. Now, there are several ways that we can look at this. Okay, so first off, let's go on and do library tidyverse to get us started. Now, the next thing that we want to do is we'll be looking at, for example, a categorical variable and a continuous variable. We can also look at, for example, continuous and continuous, categorical and categorical. Again, it just depends on what we want to look at. So first, let's do ggplot, and we look at our data. We're going to do our diamonds data set again. We want to have our mapping here and our aesthetic. X is going to be our prices. And then we want in here our geom frequency plot in here. Mapping, again, we want our aesthetic, our aesthetic here to be, color is going to be our cut. And then we're going to have our bin width in here. We'll make it 500. Now, let me pull this out just a little bit here. Now, again, we're talking about this. The default appearance, again, with our frequency plot here is going to be with these lines. Now, it's sometimes going to be quite difficult to maybe do some comparisons or whatnot. But again, we're still looking at these count values, okay? Now, again, we can see that this price kind of varies a little bit over the price, okay? So, for example, we even have these little upper levels here with our count in this mid price range. Now, we can also see that there's also, again, when we get these really expensive ones, this price, there's definitely significantly less of those down there. Now, it is definitely hard to see the difference between the distribution of these, though. So maybe let's go on and look at, again, let's go and look at our geom bar. Geom bar. Our mapping here with our aesthetic, and we're going to do x is equal to cut. Oops, cut. So again, when we take a look and we maybe want to compare these, okay? Maybe we want to swap out our x-axes. Maybe we want to look at a little bit of the density instead of displaying like these are here just count features in here. Now, if we want to display the density, okay, which is going to be a count standardized so that the area underneath, okay, so underneath, let me go back here. Notice here, this isn't really standardized, okay? We're just looking at the counts, but we want to have this standardization of everything underneath these curves here to be of a density of 1, okay? We can actually go through and do that. You know what, let me just actually go on and plot everything out, or type everything out so you guys can see it clearly in here. So we want ggplot, our diamonds data set, in here our mapping with our aesthetics is x is going to be our price, y here is going to be density, plus in here we have our geom frequency poly with our mapping is going to be here with our color. It's going to be cut in here, and then we're going to keep our bin width here of 500. Oh, and we actually need to do a bit of changing in here, so hold on just one second. Okay, so found the error that I was looking for in here, and it was actually right here. I had mappings instead of mapping. So we run this, and then we see here that everything is now standardized, so the area underneath the curve is 1, and we can actually give a proper comparison. So again, there's it's not really surprising anything about this plot. Again, again it's going to appear that these fair diamonds are going to have a higher quality, and again they're going to have the highest average price. Um, so again, maybe we want to look at these maybe a little bit hard to interpret. Okay, so I would actually suggest going through and doing a box plot on these to see what we could actually do. Now, so let's maybe talk a little bit about, we'll talk about these box plots here in just a second. So let's plot data is going to be our diamonds. We want our mapping in here with our aesthetic is going to be X is going to be cut, Y is going to be price, and we want a geom box plot in here. Now, what actually is happening in here? Okay, when we talk about a box plot. Okay, now technically we have a categorical on our x-axis. Y-axis is going to be a continuous variable, and then we have technically in here each of the plots. Now these upper plots in here are going to be our outliers. The whisker, okay, that we have here is going to be as the whisker is to the furthest non-outlier point, so that would be about right here, okay, right here, right here. Now then we have the 75th percentile here. Here we have the 50th percentile in the center line. This outer line here is the 25th percentile, and so this whole section in here is the interquartile range. This whisker here is 1.5 times the interquartile range. Now you can also say that this is, sometimes people say that this also even helps kind of with like a histogram a little bit, okay? Because you have all of these areas here, and you could map these out to the sides, as well as maybe plotting everything. And maybe we can try that with like a violin plot or something in the future. Now, what do we actually see about this? Okay, now we see a lot of less information about the distribution again, because we don't have actually the value or the histograms in here at all. Okay. But box plots are very compact in nature. And again, they all fit kind of on one plot, so it's kind of nice. Now, it does supports the counterintuitive findings of finding better quality diamonds are cheaper on average. Okay, so better quality diamonds, again, so here notice these fair are actually pretty expensive. They go down, and then when you get to premium, they go up, and then notice here we go back down. This ideal is significantly cheaper. Now, again, this is maybe counterintuitive, but actually, if we look, maybe we dive a little bit deeper, we'll actually find some reasonings behind that, okay? Now, cut is an ordered factor, okay? So this cut, okay, is a category, but it's also ordered. Fair is worse than good. Good is worse than very good. And again, ideal is the best here. So, again, many categorical variables don't necessarily have an intrinsic order, so you may want to order them in just the way that you want to display the information, and you can use that technically with a reorder, okay, the reorder function. So let's give that a try here. Okay, so let's grab the MPG data set. We have X here. Let's do class. Y here is going to be highway. Not Y. Highway. Highway. Here we want plus. And here we have geom box plot. And so if we run this, notice here that this, again, we have our nice box plots in here, but they don't necessarily, again, there's no real order to why you would have this class of minivans. Again, they're probably just picking it out in alphabetical order or something. Or sometimes it may just be some sort of random ordering. It doesn't make a lot of sense, but you don't necessarily see any type of trend or anything else in there, okay? So what we can do, and I absolutely love this, okay, is that we can go ggplot, data, MPG here, and then we're going to add our geom box plot in here, and then we're going to do our mapping. X is going to be reorder, okay, and then we want our class with our highway, and then our fun, here fun means for function, we're going to use the median. Okay, and then y here is going to be highway. Whoops, what did I miss here? Let's see. Oh, whoops, it expected an equal sign. Oh, notice here, right there. So I need to get rid of, what do I want to do here? I want to, oh, whoops, I need this here. This here, AE. I forgot to put the aesthetics mapping in there, and we also need to close that out over here. There we go. So now notice here that we have this reorder class highway. Now look here, whenever we do this, notice it goes all the way up, okay? So this is fantastic because now we can actually see a trend. So we do have some maybe long variable names with box plot, okay? So notice here that things are like the subcompact and compact are actually starting to get squished together a little bit. So we would want to do a coordinate flip on top of this, okay? So coordinate flip. We run this, and now we actually see that we have, that we can see kind of our trend in here, and we also have all of our full variable names or our class names here. So then it gets nice and clean. Maybe one other thing that we'd want to do, maybe later on we'd want to rename this x-axis here, but we can leave that for later. Now this is great with a categorical and a continuous. The next thing that we want to look at, for example, is when we do a categorical versus a categorical. And this, there are some ways here that we could kind of look at it. First off, we need to know, for example, like a count of the number of observations that we have in combination. One way to do that, again, is just using the geom count function. So ggplot, whoops, here, we do ggplot. Data here is going to be diamonds again, and we want a geom count. Mapping here, we want our aesthetics, and we want X is going to be cut. Y here is going to be color. And so this is kind of nice, okay? So we have our X and Y, and then here in is going to be the count of each. Now this, honestly, it makes me a little bit dizzy, okay? And we don't necessarily see a lot of, it can be very hard for people to judge the size of circles whenever they're looking. Again, so is this one actually bigger than this one? This one's definitely larger than this one. But again, maybe it's a little bit difficult to see which one between these two maybe is a little bit bigger. And so we want to maybe look at how can we check that covariation with a strong correlation, okay? So let's go on and do something like diamonds here, and we'll actually go through and just do the count between color and cut. And so now we actually see, for example, the actual values here. And I think that this actually personally is, I would actually rather just to see the numbers than I would to see this whole set of dots. However, we can use the geom tile to get a fantastic and very pleasing look. So let's do diamonds here, and we want to do count, color, cut. Okay, so this is this first one here, okay? Now we're going to add in here ggplot, mapping, and we're going to have our aesthetic. X here is going to be color, Y is going to be cut, and then we are going to add in here geom tile. Okay, and this, for some people, you could call this a heat map. Okay, so fill is equal to in. And so now we have this, this nice way to look at, again, so if our variables are technically unordered, okay, we do want to maybe look at it this way. We can look at these simultaneously. There are, for larger plots, we could also look at proper heat maps. You would look at like D3 has a heat map package, and then we also have heat maply packages as well. And those are to help you create some interactive plots. Okay, but again, this is very nice to be able to see this variation in here. It gives us a little bit more, I believe, a little bit more aesthetically pleasing than looking at the dots. So now let's look at two continuous variables. All right, so continuous versus continuous, and I'll put that as a comment. So now we've already seen, again, the covariation between two different variables before, and this is when we use a typical scatter plot. Now we can also see this covariation as a pattern in whenever we look at the points, okay? So for example, if we have an exponential relationship, a linear relationship, a log linear relationship, so let's see what type of, what we can see here when we look at the caret size versus the price, okay? ggplot, our data here is going to be diamonds. And we want a geom point with our mappings here. We want our aesthetics. X is going to be caret. Y is going to be price. And again, this may take a minute because these are pretty large. All right, now notice here, we get this great exponential curve going up. We have a little bit of outliers here and there, but we definitely have these bands of data in here. Now, they become very useful, but they can also be very, here right now, for example, we have a lot of overlapping points, okay? And so that's what we get, these deep pitch black areas. It's a solid black, okay? So one thing that we can do is we can add some transparency or alpha to our data. So what we would add in here is comma alpha, and let's actually put this 1/100th, okay? And run this, and this will give us some transparency, and then you can really see where things start to overlap. And again, this takes a second to run, but this transparency is going to very useful for large data sets, okay? Another solution is to use a bin function, okay? So when we're looking at a histogram, you can do that, or a frequency plot for, again, that's looking at one dimension. And then we can also do like hex plots or bin 2D plots as well. Now, I think probably in the next one that I would show you, again, I'm a huge fan of hex plots. So you would need to install packages here and do hex bin to install that. And we'll let that install here in a second, and I'll let that run. And I'll be back in just a second. Okay, so it finished installing. So let me clear this out, and let's actually look at data here, and I want to do something like diamonds, and we want what here? Geom hex, and we want mapping here is going to be our aesthetic. X is equal to caret. Y is equal to price, and run. And this, if you notice here, this looks pretty nice. Okay, we still have this nice exponential looking curve. There is definitely some lighter areas in here. Now we could also maybe look at one issue that we have here. Again, we have a lot of our outliers in here. We could be using that smaller data set where we got rid of the outliers. Now let me see if I still have. I do have that outlier data still. So let me go on and redo the outlier data. Oh, whoops, because that is not removing the outliers from the other data set. So I will go back. Let me just go back to this one. So again, what's nice is now hex bins themselves, okay, allow you to kind of bunch up a lot of the perspective data into these kind of bins. Similarly, we could change this instead of a geom hex bin. We could change this to a geom. I believe it's bin 2D. Oh, whoops, and I left outliers there. Okay, and actually, I think the clean data is diamonds 2, so let's take a look and see. Yes, diamonds 2 is actually going to be a little bit of our clean data. Maybe? No, it's with our missing values. But anyways, we have, you can see here, instead of our hex bins, we actually have, these are just little 2D square bins in here. And it is, I think it's actually very useful whenever we're looking at our two continuous variables, because it helps kind of bring them together. Now, another thing that we may want to do is look at a categorical and a continuous with our box plots again. And this can be very useful, for example, when we want to combine a lot of these continuous data points. Okay, so we see this, there's this upward trajectory in here, and we may want to add in a little bit more. So we can bin the carets, okay, and then we can actually show these each individually as these kind of box plots again, because everything's really dense right now. So and again, the reason that we're doing this is because we are binning. It's technically a continuous versus a continuous, but we're just turning it into a categorical. So data here is going to be our diamonds. Aesthetic X is going to be caret. Caret Y here is going to be price. Plus here we have a geom box plot in here. Mapping is going with our aesthetic here. We want to create a group, okay, and we're going to call this, use the cut width function in here, and we want just caret here and 0.1. Okay, so we're going by a tenth of a caret each time. Oh, and again, here, it's just because I mistyped mapping. Again, probably you guys at home are probably screaming at me, telling me that my typing skills are abysmal. I know, I'm sorry. So this will run, and now we'll pull this out. And notice here, we get this nice upward trajectory in here. And let me go through, and I think in my environment, okay, I do have that smaller data set. Let me actually go through and do that, because notice here, there are a lot of the outliers that are popping up here. So let me change this back to the small data set. If you want to know how to do that, go back and look in some of our previous videos. And now, so here, notice we actually see that, yes, caret is continuous, but we bend it by these tenths of a caret. Okay, so it's moving upward. And then we also have our price. So we still have two continuous variables, but now they definitely look a little bit cleaner. We can see how this means and the median's changing over time, how the distribution's changing over time. We can also see those outliers here and there based on the distribution. So this gives us a lot of very cool information going on. Now, another approach that we can do here is actually, instead of doing this cut width by, for example, by 0.1, okay, we can actually up this, and we can change this instead of this width. Okay, we can just do it by number. We can actually grab this count, and we can say that we want to grab 20 at a time. Okay, and so notice here that this actually grabs just 20 observations at a time, and you can see here that they get you can see that this distribution kind of changes over time a little bit, okay? So it takes more and more and more, because remember, all of these up here were relatively rare, so they take up a lot more space to get 20 than down here. 20, there was a ton of them all up in here. You see these little bitty box plots, and they go all the way up. So again, I hope that this is very beneficial to you guys. I suggest that you guys play with it as much as you want. If you guys have questions, ask them in the comment section. And if you like this, please subscribe and hit that like button, and I'll see you guys next time. Bye-bye.